Shazam is one of the best applications produced. It is used by more than 1 billion people all over the world. We use Shazam in everyday life to find our favorite song. But have you ever wondered how Shazam works? The quick answer is audio fingerprinting, which leads to another question. What is audio fingerprinting? Soundtrack can be played in many instruments, and that makes the identification part difficult, but anyway Shazam can identify it. Why is that? Different instruments have different timbres, but that doesn't mean that they differ from each other. That's why the main part remains the same. So we need a way how to convert these characteristics for computers. This is where spectrogram comes in. A spectrogram is a visual representation of sound. It's a three-dimensional graph with time in the x-axis, frequency in the y-axis, and amplitude of the frequency in the z-axis, which is often represented by a color. This way, this 3D graph is something a computer can absolutely recognize and store as data, but there is a huge amount of spectrograms like this, and the more data there is, the more computation time is required to find a match. That's why Shazam uses audio fingerprint, transforming each spectrogram in a simple way, more exactly in a 2-dimensional way. When you open your Shazam in your phone, it starts creating a specific fingerprint, ignoring the other voices which aren't part of default frequency. Once that has created the fingerprint, it then sends it to the Shazam servers where the recognition part of the process begins. This is where things get difficult. Shazam searches to see if several nodes exist separated by a particular time. This becomes our searchable address for a hash table. Hashes and hash functions are an incredibly useful technique that appears everywhere in computer science. A hash function takes a varying length of input and produces a fixed length of output called a hash. Now imagine, our hash function takes data from our two frequencies separated by a particular time as an input and produces a number between 1 and say 1 billion. First we go through our database of songs and calculate the hash number for each anchor point. Songs will contain multiple anchor points, which will allow us to categorize them using the frequencies and the time between them. In the end, we store each anchor point in the order by the hash. Then, these addresses are also categorized with songs IDs and other stats helping us find the right song. This is an ingenious method of song recognition, and this makes it worth over $400 billion.